Hello, I'm Goffert from Excel DNA, and today I want to talk about Excel DNA in the perspective of Excel add-ins in general, and talk about what .NET and Visual Studio might mean if you are unfamiliar with those and coming from an Excel and maybe a VBA programming background. Excel DNA is a library I started developing in 2005 that glues together Excel with the Microsoft .NET platform and the Visual Studio tools used to develop code in .NET. Excel DNA is used to make Excel add-ins with .NET. The name Excel DNA is kind of a riff on Visual Basic for applications. I think of it as being an alternative, which is to use .NET for applications, hence Excel DNA. Visual Studio and .NET are Microsoft development platform and tools that might be quite intimidating if it's stuff you don't know about. And even if you are a .NET developer, starting to make Excel add-ins might be something you're nervous about. But Excel DNA is the right tool for that. And I want to assure you that Excel DNA is a safe and non-toxic tool. And so you can give it a go and you might find it fun and easier than you think. Let me say something about the kind of add-ins that I'm interested in making. These are ones that focus on functions first. So I want to show you in Excel what I mean by that. So here we have a table with some stock price data for Microsoft from a number of years. And what a user might do, this data might have come in from file or from Power Query in some way, something like that. And a user might be interested in now developing a model that will further add calculations to this data. For example, he might add a rate of change formula. And what I mean by that is just how has the current price minus a previous price changed relative to that previous price B2. In this case, it looks like Microsoft's price actually went down in 2011, but then their fortunes changed quite a bit and it got much better. So that kind of formula is fine, but there is a problem. You can make mistakes in typing it in, of course, but also it doesn't have any meaning in this sheet. It's just an arithmetic formula that sits there. So one thing one might do, and that I would encourage, is to encapsulate a formula like this in a user-defined function. And I will show you what that means in VBA and then later in an Excel DNA add-in. So in this case, I've added a new module and I have defined a function called rate of change, and it has exactly the same calculation. It's the current one minus the previous one over the previous one. And this rate of change function I can now use in my sheet instead of that formula. So if I now go back to my sheet, I can, instead of this formula, say this is equal to rate of change, and I am going to say this is the previous one, rate of change, previous, comma, current. And I'm expecting the numbers to be the same because the calculation is the same. But now my spreadsheet has a name for this calculation. I know that I will always be using the same calculation. I can encapsulate that function into an add-in and give it to other users who can also use it in their models. And I've enriched the semantics of this sheet. So that's one kind of function, a calculation function. Another kind of function is one that might just bring data into the sheet using functions. I'm a big fan of these too. So this data actually didn't come from Power Query or from some file that was imported. It's actually getting the data in from a function called stock price that I've made and will show you more about. And it is a function that takes a code and a date, and it retrieves the stock price from a local database. That is a cache of data that was downloaded from Yahoo earlier. And so this is similar to Microsoft's new stock history function, perhaps. But I think because it is a fast single cell function, it has some advantages over a function that will return a table of data. In this case, we can change the code and turn this into NVIDIA or some other company. They've also done fairly well over the last decade. And if I go to the other sheet here, I've got actually quite a long list of dates every day for the last 20 years. And the function is fast enough that it is responsive as I change this from Amazon to NVIDIA. It recalculates this quite quickly. And I think that's one of the important attributes that a data access function like this needs. Of course, once you've got data, it's easy to make a graph or something. But the point is that you can also have a user who decides he wants a different layout, kind of a transpose maybe of that kind of layout with the dates and codes along the side. Or he might have a single date that he wants to change and focus on, and then use this function in a table. And so in this table, I've using the same stock price function with the code and the date. And if I now add or remove rows here, there won't be a problem. I can see that this table will calculate also using the table columns correctly. So that's quite nice. And I can even summarize the total of the value by just using these table references. So a key that makes it easy for you to use this kind of function in different environments is that it is just a function bringing in data into a single cell. In other circumstances, we might want to get an array of data or something similar. I will talk about that too a little bit later. Okay, so the kind of add-ins that I'm interested in are ones which that incorporate calculation functions or data access functions or other utility functions. So I see the functions first perspective on add-ins as being the focus for Excel DNA mostly. Excel DNA is useful for everyone who uses Excel. You should know about it, and you should know that even if you are not a programmer or a developer, maybe you want to deal with programmers or developers who can help you extend your Excel. So I think Excel DNA is for you. It's also a good library to know about, even if you are developing code in other languages, because Excel DNA is the best add-in framework for Excel. I think of the world of Excel users as having a subset called the add-in users. They are Excel users who have some add-ins and thus have a stronger and more capable tool in Excel because they've extended it with these add-ins. And among the Excel users, some are, of course, VBA developers of some sort or power users. And then some Excel users are actually Excel add-in developers or Excel add-in users, Excel DNA add-in users. Then among all the programmers, I think that some of them are programmers that intersect with this world of Excel users and Excel add-in developers. And of course, some programmers are .NET developers. And so in general, Excel DNA sits in this interface between Excel and the programming world. And my enthusiasm is that more Excel users must become Excel add-in users and have a more powerful tool. My enthusiasm is that more developers must become .NET developers because it's a great platform and framework. And one of the reasons is because it's easy to make nice Excel add-ins with .NET. Then I hope that more VBA developers might become .NET developers and make their Excel add-ins that way. And so at the end of the day, I want there to be many Excel add-in developers that are using Excel DNA or other tools, but my interest is Excel DNA. Okay. What kind of add-ins do people make? Well, there are calculation add-ins in the finance world with quant calculations and derivative pricing. There are engineering front ends for things like chemical process simulators. This is an open source chemical process simulator with an Excel add-in that's a front end that can talk to the simulations as they run. Some add-ins are data access add-ins for back-end services of different sorts. And then some add-ins are utilities that can be used in all kinds of places. For example, something that does regular expression, string matching, and that kind of thing. For many companies, it's really valuable to be able to encapsulate shared calculations that are developed by a development team in a way that is accessible to many different kinds of users, including Excel model, people who are building models with Excel. Another important thing in companies is often to have one truth, or one true source of data, one true value of what they think the interest rate was at a particular date, and one source of estimates of and projections into the future that can feed into all models that people build with Excel. So calculations, algorithms, and data can all be made accessible in a standard way to people who are using Excel as a front end and still are able to flexibly build their own models and use these shared calculations and shared data for that. There are many kinds of add-ins people build, and all of them can be built with Excel DNA, but there are other tools as well, of course. Why can't you just use VBA for all of it? Why would you even bother trying to learn about these complicated things like .NET and Visual Studio and new kinds of tools? Well, there are some reasons. I've tried to list some of them. One is that there are Excel features that are not available in VBA and that might be useful to you, like fast multi-threaded calculation or making streaming functions which push data into the sheet quickly and efficiently. So sometimes code and some of the Excel interaction can be faster if you are using some of the other ways to talk to Excel and not just VBA, or if you're calculating in a different kind of runtime environment. Other languages and platforms like .NET often have access to many useful libraries, and so you don't have to rewrite all of it yourself, but you have easy ways to integrate with libraries that are already existing. Also, you can access more powerful development tools like the Visual Studio development environment, or languages that give you a higher level of abstraction for expressing ideas in different ways. In a corporate setting, sometimes there are already developers using some kind of platform like .NET and C#, and then using ways to integrate those languages that are already being used into Excel can become important, rather than insisting that they have to do stuff in VBA. It's not the only way to extend Excel. An advantage of using something like .NET is that you can take some of the code that you use in your add-in and also use that as the calculation that sits behind a website or in some other kind of project or environment. And that's an advantage that VBA struggles with because it is isolated in the Office environment. And sometimes it's just fun to learn something new. But when you want to learn something new, you might not want to let go of everything you like and use. And if Excel is something that you find powerful and that you use, you might want to learn some new language and get used to the bigger programming world without leaving Excel as your substrate for doing your work in or for doing your kind of modeling. It really is a great tool, and so it's nice to extend it rather than to leave it for some other completely different environment. Okay, the Excel add-in universe, if you're making Excel add-ins, consists of I would say, a confusing array of options, including Excel add-ins, COM add-ins, and then JavaScript add-ins, which aren't even on the normal Office add-ins list here. So this can be a confusing world. So let me give you some idea of how I see it. Under that Excel add-ins option, there are the VBA add-ins, and then there are XLL add-ins, which are these native code add-ins developed with what I mostly call the C API, and it's as described in the Excel SDK. So these XLL files are ones that you might make with Excel DNA or with C++, or you might even see this XLL integration into Excel with tools like Pixel and Jinx, which Tony Roberts spoke about earlier. The XLL add-ins are the best type of add-ins for adding user-defined functions to Excel. So the type of add-in that I'm enthusiastic about, they are really the XLL add-ins. COM add-ins, on the other hand, allow you to extend the ribbon and to add macros to Excel. Traditionally, these could be written in VB6, but that's not around anymore. And then for .NET, there's a whole bunch of ways to make COM add-ins, including VSTO, which is not developed anymore, but is still available from Microsoft. It's the Visual Studio Tools for Office, is what that stands for. And then libraries like NetOffice and tools like Add-in Express, which is a commercial tool that really helps make add-ins for the various Office tools like Outlook and others. And then there are JavaScript add-ins, the new kid on the block that there are many talks at this conference covering. And it's kind of Microsoft's current plan. They're nice because they are cross-platform and so work on the online version of Excel and on Mac as well. But they don't have all the functionality that Excel DNA add-ins have. And it's an environment and language that is much more foreign to most people who are either coming from an Excel background or from a .NET background. And so Excel DNA fits the niche of matching more closely with what most people who want to make Excel add-ins already know. JavaScript is quite foreign to that often, I think, but we will see in future how things develop. I should also say there are many ways to read and write Excel files from other programming environments. So this is libraries that can generate an Excel XSLX file or other Excel files, or read them and interact with it in that way. That's quite a different topic and quite a different area to what I'm thinking about as an Excel add-in. Okay, now suppose you are interested in learning more about .NET, but you don't know much about it, and you've seen all these many terms like the .NET framework and the different languages and the Visual Studio tool and other related things, and you might be quite intimidated by the many terms and things to learn, and then you just ignore it again for a while. So I want to encourage you to have a look again, and I want to say it doesn't have to be so scary. So let me orient a little bit the .NET framework and related concepts and what one might need to know to actually get started in this environment. So the .NET platform was announced in July 2000, that's 20 years ago exactly, at the Professional Developers Conference. And it was Microsoft's successor in a way, or replacement for Java and the Java runtime. And it was also intended as the replacement for Visual Basic VB6, and so it would be a combination of Microsoft's various development tools as a one runtime, and that could combine the next version of both Visual Basic and a Java-like language called C#. And so the .NET platform consists of a number of programming languages and compilers, and a large base class library that provides basic functionality, and then a runtime environment where things operate, including features like memory management and garbage collection, and that just-in-time compiler and such things. So in the .NET platform, there are three main languages. There is the Visual Basic version that I normally call VB.NET, but in most of the documentation on Microsoft's site and elsewhere, it's just called Visual Basic. It has a similar syntax to VBA, and it's somewhat compatible with VBA, but it is also different enough that it's not just so easy always to just move from one to the other. But it has the advantage of being familiar syntactically, and in the way it looks and feels is much more familiar to something coming from a VBA background. C# is the more popular language on the .NET platform, and it's the one that is evolving with new features the fastest. And then F# is kind of the quirky cousin that is a functional language in the style of ML. And it is popular amongst people who like something that is a very succinct and powerful language, and is not bothered by the fact that it's not used very widely. And I should make clear that F# is completely supported by XLDNA for all the functionality. All three of these languages you can do anything with. And so the choice between C# or VBA maybe doesn't matter so much. Another thing that is confusing is that there are different .NET flavors, and you'll see these choices in different environments. There is the .NET Framework, which is the one that is the Windows component and is currently at version 4.8, and that's the one we are targeting with XLDNA at the moment. There is a cross-platform version and Linux, iOS, and Android versions of .NET. There is also something called the .NET Standard, which is a way of making libraries that target all the different runtimes. And then the future is going to be .NET 5, which is the next version of .NET Core, but incorporates all the functionality, nearly all the functionality from .NET Framework. And that will be released around November 2020. And it will be the future stream of .NET. So that's the next major version of .NET. For our purposes, we will always choose the .NET Framework, and it is important because that's the one where the packages and everything work best in Visual Studio for the moment. Why would you not use Python or some other language? Why would you use the .NET platform? Well, I've been using .NET for nearly 20 years now, and I think it has a combination of very expressive languages, extensive libraries, lots of popular use, and so it's easy to get support and developers who are familiar with it. And it's a great combination of great performance in the runtime and good expressive power in the language, and access to libraries. So it's a good combination that balances all the things that are important. Great tools, great performance, great languages. But the other options are certainly valid for specialized reasons. And if you are familiar with Python, then you should make your add-ins with Python maybe. Or if you are in a company that uses Java for your development, you should make your Excel add-ins with Java. Or if you are interested in web technologies, but also want to make a little bit of interaction with Excel, maybe the JavaScript add-in approach is best. So there are certainly valid reasons to use other tools. But I have been very happy with the .NET platform and think I will be using it for a long time still. And one thing is certain, and that is if you are using .NET and you want to make an Excel add-in, then Excel DNA is the right tool for that. It is the right glue between Excel and .NET. Visual Studio looks a bit like VBA. If you just open it up, there's a page with some code, and there's a solution project tree. It's on the right hand side and not on the left, so it's a little bit different. But it's somewhat familiar, so it's worth installing and giving it a go and not being too worried. If you go to visualstudio.microsoft.com to install Visual Studio, you are faced with some choices. You need to choose between these different flavors of Visual Studio, and the right one for us is the real Visual Studio, which is the version that runs on Windows and is called Visual Studio. Don't choose any of the others. Which edition should you install? That's the next choice you might face. Well, the answer is, if you're a small company, if you work in a small company, or you work alone, or you work in an academic setting, then you choose the free community edition. And if you are in a big company, then you might have to find out whether your company already has a license for Visual Studio, or whether you need to buy Visual Studio, the professional edition. But the community edition has all the features that you need, and it is completely free. So it's the one that for many users, it's just the one you should pick. And then when you install it, there is another set of choices. Visual Studio is an enormous tool with many feature sets. And so for our Excel DNA development, the choice to make is to install the .NET desktop development workload. That's all you need. There is also an Office one. You don't really need that for Excel DNA development. But if you want to do SharePoint integration or something like that, maybe you can have a look. But the right tool in general is the .NET Desktop Development Workload. There are two more sites that you need to know about that's relevant to our Excel DNA world. The one is the NuGet Package Manager, where you can download many libraries and install them as part of your project. And that's where the Excel DNA.add-in package lives. And that's the one that makes your project into an Excel DNA add-in and integrates it into Excel. So that's the one that we'd need to install. Also, the GitHub project hosting site is of some interest. That's where the Excel DNA source code lives. And you can host your own projects, private or public, on GitHub as well. You can think of GitHub as, among others, being the successor to something like SourceSafe as the current source control system, and project hosting site, and much more. So that's something to know about. Okay, now I want to talk about some of the bits and pieces that go into making an Excel DNA add-in. And in particular, I want to show how one would get started making a new add-in. I want to talk about a strategy for dealing with Biggish data, data that's such that it would not necessarily fit into an Excel sheet, but isn't enormous. And then I want to say something about the dynamic arrays and where I see the future of that kind of thing impacting these function-focused add-ins like the ones with Excel DNA. So let me show you how to make a new Excel DNA add-in. I'm going to go to Visual Studio, and I'm going to create a new project. And when you make a new project in Visual Studio, there are many templates to choose among, and so that can be a bit confusing. So if you look for the ones that are libraries, they're the ones that we would use for an Excel add-in. I've chosen here the Visual Basic language, but if you want to make a C# library, then you would choose C#. And there are some choices already here that I have to make carefully. Like, do I want to target .NET Standard, .NET Framework, or .NET Core? At the moment, it's important to choose .NET Framework, because that's what Excel DNA supports at the moment, is a class library that targets .NET Framework. So I'm going to make that, and I will just call it demo, and I will create it, and it will make my library project in Visual Studio. There we go. And I can see it's made a little file called class1, It's got no code in, and I see my project tree with my references. These are the default system references it's added, and then my file. Okay, to turn this library into an Excel DNA add-in, I need to add that NuGet package. So I'm going to go to Manage NuGet Packages. I can also pick it from the menu here. Tools, NuGet Package Manager, Manage NuGet Packages. And what I want to do is I want to browse and I want to go and have a look at packages that are Excel DNA packages. And I will find a few here. The one I'm interested in is called exceldna.addin. That's the one that will turn my project into an Excel DNA add-in. And there's a bit of a story in the description, but I can just pick, yes, I want to install it. And then NuGet will ask me, do you want to install these packages? Yes, I do. And now it has made the references that are needed. It has added my DNA file, and all of these things are explained in the README that it shows. It also shows what will happen after I compile. So it's worth reading this if you haven't seen it before. I've seen it before, so I'm going to close the README and I'm going to go back to my code, and I'm now going to put in a function that I can use from Excel. That's the kind of thing I want to do in an add-in. So I am going to change this from being a class to being just a module, a public module, and I'm going to call it my functions. My functions, and I'm going to put a function here. Maybe I will put a function here called rate of change. And I will say previous current, and I will say rate of change equals current minus previous over previous. Okay, great. So I've defined my function. You'll see the code is exactly the same as the VBA code we had. Doesn't always work that way. Sometimes the VBA code and VB.NET code in Visual Studio is not the same, but sometimes it can be quite similar. Okay, now I'm ready to compile and run my add-in, so I'm just going to press start. I expect this will compile the add-in. I see at the bottom it's busy compiling, and now it will start Excel and it will ask me, do I want to open my demo add-in? Yes, I do. I'm going to enable it, and I'm going to make a new sheet, and let's see if my function is here. So a rate of change, it's there, and I can say, okay, previous, current, okay, 0.5, and as a percentage it's 50%. That looks about right. If this is 1.2, it will be 20%. I can even go back to Visual Studio at this point. I can put a breakpoint F9 in my function, and when I go back to Excel and I evaluate it again, it will break in Visual Studio, and I can examine the values of the arguments and so on. I can even change the code if I want to. It's probably a bad idea. My calculation will go weird, but at least, okay, I can edit it, I can debug it, I can run it. I've made an add-in. Okay, that seems pretty good. Okay, so that's how you get started making an add-in. How do you make an add-in like the stock price function I had, which was a fast lookup into a database? So let me show you how that worked. The data was stored in an Access database, an ACDB that I made with data downloaded from Yahoo. So this is the Access database, and it has one table in called stock history. And this table has a code and a date, and then the main information for that share from that date. This table is fairly large. It's got let me see the bottom, I think it's 3.6 million records. So it's larger than you can fit into an Excel sheet, and it's certainly so that if you put too much data in an Excel sheet, it becomes hard to access using the XLOOKUP and other related functions. So it's nice when it's in a database. But the really important thing is that this table also be indexed in the right way. So if I go to the design view for this table, I'll see that the code and date fields have been put into an index called code date. And this index is what I will use to actually look up the data directly. So I'm not going to do SQL queries. I'm going to use data access objects to read this, to position a record set onto this index and then read the data from there. That's extremely fast. And it's extremely fast even for quite a large database, maybe even 10 times bigger than this. It wouldn't make that much of a difference. Okay, so there's a stock history table. It has a code date index, and I want to use this from my Excel function. So let's see how to do that. So I go back to my demo add-in, and I'm going to add a new module. So I'm going to say add module, and I'll call it stock data. And I have actually written the code already that I want to use. So I'm going to copy that in from another place. This is the code I'll be using. And I can already see, oh, things are bad, there are errors. It's because I have not added a reference to the data access objects that I want. So I want to talk about databases and record sets, but I haven't added the reference I need. One way to add a reference to the data access objects is to just add the NuGet package, and it's a package called exceldna.interop.dao. I'm hoping it's on the list here. There we go. exceldna.interop.dao. This is an assembly that gives us access to the data access objects. And so that makes it very convenient. And I think we will now find that our problems go away. All the squiggles have gone, everything compiles. And let me have a quick look at what this module does. This is all the code. There's a sub and a function. The sub initializes stuff, and the function then is the single data access one. To initialize it, I'm just opening this database, and then I do open record set of that stock history table. And then this is the really important line. It's where I set the index that I will be using to that code date index. And so this record set type it's a direct table type record set, and I can set its index, and then I can use the magic function called seek, which is really the way that you look up things very fast in a record set. So whenever stock price is called, it checks that it has already initialized the record set and database, and then it does this seek method to position a cursor in the right place in the table, and to read then the code and the close value in the way that, if you are familiar with data access objects as a library, that will work the way that you know. So I should say that the data access objects is very convenient because it's installed as part of Excel always, which means that for 32-bit and 64-bit versions of Excel, you can use the same add-in. This add-in will work. You don't need any kind of permissions or install any kind of access runtime or anything like that, because it's already installed as part of Excel. So it's much more convenient to use than something like SQLite, and it is much faster than something like SQL Server, which will live outside the Excel process and will need a different approach to bringing the data across and into the Excel sheet. So this kind of function can be very fast. You should think of tens of thousands of iterations per second without a problem, even for a table like the one I've got here. Okay, so let me run this again and load it in Excel and see how things go. So now I'm expecting that I can say equals stock price, MSFT, and give it a date. And I think this will work. And again, I can go back here and I can put a breakpoint, and when I calculate it, it will stop at the breakpoint. This code is my code and date, but this .seek really is the thing that makes it fast. And it allows me to do a sparse lookup, a less than or equal to kind of lookup, So I can store the data in a sparse way and still effectively look the data up in this inexact way, which makes the database smaller and the lookup fast. Okay, so that's my data access function, and I've got it running and everything is fine. Okay, I might open the old file we had. And so on this sheet we can see that recalculating the many thousands of entries here is quite fast. Okay. I want to now talk a little bit about one more way in which we might add, in which we might access these kind of functions and this kind of data, and that is to do with the new dynamic arrays functionality that is in Excel. One of the really nice new features in Excel in the last year or so has been the addition of dynamic arrays, and it allows us to have functions that return into a large array from a single cell. For example, the sequence function will return 100 values, or whatever number of values we say, so we can bring this in from another cell, and as we change this cell, the size of our result will change dynamically. That's why they're called dynamic arrays. If we have this sequence, we can actually get a list of dates by just taking a starting date and then this kind of sequence being added to that starting date, and that will give us a bunch of dates. And as we change the size here, our list of dates will change size dynamically as well. So that's kind of convenient. And then dynamic arrays also work with the built-in functions. So the transpose function, for example, if it gets all the data from a table where I've got this list of holdings, then if I change the table, this transpose dynamic array function will also change. So if I add apple in here, you'll see that it's changed at the top here, because transpose is an array-aware function that will understand as the table grows, it must have a growing result that it returns. So what I've made as an experiment is a little function called ARRAY.MAP to, and it will map a function like my stock price function, which takes one date at one time, and it will apply it to a whole list of dates and a whole list of codes. Got the wrong way around now. Whole list of codes and a whole list of dates, and return the result as an array. So to enter that, I say excel.map to, and then I give it the function, which in this case is the stock price function, but I don't put the brackets in, so I delete the bracket. And then I can put a whole list of codes. So in this case, I can put the codes with the hash array identifier, and I can put the whole list of dates again with the hash. And so that way, my stock price function will now be run for all the codes and all the dates, but the result will be a single dynamic array. And so that's convenient, because now that whole thing is still an array. Like the built-in functions, my user-defined function now preserves arrayness, and I can continue calculations with this as an array. I can filter and sort and do other things. And all of this is dynamic. So if I change the number of days here to 20, then my list is extended and my array is automatically made bigger. If I add another code here, Amazon maybe, and I put another 30, my array at the top has automatically expanded, and my user-defined function has now automatically expanded because I'm making it array aware with my array.map to utility. I think that thing is not formatted right. It must be a number. There we go. Okay, And then we can go a little bit further with this array idea. Because it's an array, if I've got my dates again, then I can say, how am I going to evaluate these share prices against these quantities that I might have as holdings? Well, it turns out this is just a matrix multiplication. And so my value for that date is just a multiplication of my array, resized array of stock values multiplied by my list of holdings. And that gives a value for every date that is correctly calculated. And as I change my quantities, I expect all of those values to update. And all of this, again, preserves arrayness as we calculate along. So as I make this small or large, the whole sheet size resizes itself. And as there are fewer or more entries in this table, the sheet will automatically change and recalculate. So this is the magic of the new dynamic arrays feature in Excel. And the really important part of this is that we need our user-defined functions to also become dynamic array aware, just like the built-in functions like transpose have been made. And this ARRAY.MAP to helper, which is an Excel DNA sample, which can help do this kind of thing and play with dynamic arrays a bit more. Okay, that is some of the highlights I wanted to show. Things I've not shown in this case are other features of Excel DNA, like streaming functions that bring data in, push data into Excel using the real-time features, or the fact that with Excel DNA you can easily also make ribbon extensions, even for users that are not administrators, which is quite nice. And then if you need more help in using Excel DNA, there is the Stack Overflow website for all programmers and all programming questions, and it has a tag called Excel DNA, which I try to watch. And then if you go to the Excel DNA Google group, there are thousands of discussions that you can search for there that people have asked questions and I've tried to answer and other people have answered. And so that's a great way to ask any questions if you're getting started or trying to use Excel DNA in some way. That's the best way to ask. Okay, so that's Excel DNA in perspective. And what I've tried to show is that Excel DNA is a tool that you need to know about, and it's something that you might even want to use. And if you're nervous about getting to know .NET and Visual Studio, you shouldn't be. You should learn about it and you might enjoy it and find a lot of power. And finally, Excel DNA lets you make add-ins that are composed of various components and ideas working together to make something that is vibrant and alive and could become an ecosystem of add-ins that make your Excel and your users' Excel a more powerful tool even than it already is. I want to thank especially Chris Miller, who is the initial motivation for starting the whole Excel DNA project 15 years ago and has been a great support all through. And Kevin Trethui, who really showed me what the value is in a corporate setting of this kind of tool and gave me a perspective on how useful this really can be and how that value is unlocked. David Carlson, who helped with the documentation generator tool, and Caio Augusto Proete, who has been a great help over the last few years in improving our build system and is always keeping me on my toes to make Excel DNA better. Thank you very much. And then to all the Excel DNA users over the years, this project is for you. And I am very glad for people who have found it useful and have given feedback, and I hope to continue for a long time. Thank you very much, and I leave some slides at the end for the evaluation form and Microsoft's request for assistance in further Excel work. But thank you.